Okay, today we're going to be looking at some very simple maths on statistics and some analytical geometry. So I'm assuming you can see my PowerPoint on the screen. Okay, we want to discuss median, quartiles, interquartile range, and box plots. That is our focus in grade 10. So if we look at our example that I have here, we have two dice. We're thrown 10 times. And we see that the scores were added together and recorded. The first question is to find the mean and range of this data. So let's try and understand the word mean. Can someone tell me out there, what does the word mean to you? Let's go to mean word.
Means average.
It means average. Well done. So to find the average, we know that we're going to add all these numbers together and divide by the number of numbers. So to find our mean, we can take our calculators out. We add everything together and we divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So that's quite easy for us to do, and we would get 7. So we come across the first word, mean. Mean means to find the average. To find the range of the numbers, it's basically your maximum, which is 12, subtract your minimum, which is 2, and that gives you 10. So we're going to move on to the next one. So we're going to talk about, sorry, before I go there, we're going to talk about the median. What is the median? The median is the middle value of a set of data where the data has been ordered, or you could say sorted. So we got to sort the data first. So if we look at the example I have here, Robert hit 11 balls at Grimsby driving range, and we see all the distances are recorded. Now you notice that the numbers are not in order. So our job firstly is to go arrange this in order. So remember, to find the median, we have to first sort the data. To find the mean, the average, data does not need to be sorted. So when I sort the data out from smallest to the highest, you can see 50 came in first and going right up to 140. Now, to find the median, okay, before I actually put out the median, let's count how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we have 11 numbers, in which position will our median be? Somebody can tell me that? What position will the median lie in?
Number 6, sir.
You say 6. So if we had to listen to that young man and go with what he's saying, I remember what he said was 6. So 1, 2, 3, 4, 5, 6, we get 85. So let's count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So on track, we can see that the median is sitting on position 6. Now, what happens if we have an odd set of numbers? That'll create a little bit of a problem for us. Okay, we'll take that case a little later. So remember, if we have an odd number of numbers, we've got 11, which means we have an odd number of numbers. To find what position, and that's very important to understand the position of the number. Because if you've got over 120 numbers, we don't have the time to count. So we need the position, okay? So we've all discussed that that will be in position 6. I want to make a note of that. So going to another case.
Sorry, sir.
Yes.
Some boys want to join, sir.
Okay, let me just quickly admit them in. Okay. So as you can see, it's quite easy work. Now, in this one, we're counting a number of numbers and they're telling us it's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we got 12 numbers, where will the median lie?
So you'll take number 6 and number 7 and you'll divide them by 2, sir.
Okay, so if you have an even number of numbers, your median lies in the center. So 12 divided by 2 is 6. So the median will be between 6 and 7. But if you have an odd number of numbers, the median will lie on the actual position. I mean, if we had 11, 11 divided by 2 is 5.5. And if you round off 5.5, it's position 6. So we got to firstly order the data. We're going from 50 to 140. And then if we now count 1, 2, 3, 4, 5, 6, position 6 and position 7, and we can quickly check this. And how do we check this? If we look on the left, if we looked on the left of 85, we have 1, 2, 3, 4, 5 numbers. And on the right, we have 1, 2, 3, 4, 5 numbers. So the median now is not on a number itself, but the median now will lie, the median now will lie in between, and I'm going to make a note of that. So in a case like this, the median is actually in between, which will be 85 plus 70, 85 plus 95, and divide that by 2, we would get 90. Now, let me tell you what happens to a lot of grade 10s. They will type this on the calculator, 85 plus 95 divided by 2, and the calculator does not give them 90. Try it out, guys. Check if I'm right. What does the calculator give you? Somebody?
So I got 132.5. So
Now tell me why you're getting 132.5.
So I put it in the calculator. It's 85 plus 95 divided by 2.
So the calculator is doing board math. It's taking a 95, it's dividing it by 2, because it'll do multiplication first, and then it will add the 85. So what you got to do is make sure you use your bracket. So you'll have to say bracket 85 plus 95, close the bracket, then you divide it by 2. So don't make that mistake in the exams. All right. Let's move on. So we move on to quartiles. So the first thing, let me just tell you, the first quartile we know is the median. The median is actually quartile 2. So if we have a set of data and we're dealing with quartiles, your first thing is go and order the data. In other words, sort the data out. All right, I'm going to give you some time. Quickly sort the data out on a page. I'm hoping you're working on a page there. Did anyone sort out the data? Somebody would like to call out the ordered set of data for me?
I'm done, so.
All right. So guys, I don't want you to be watching this video now. I want you to be working with me. So writing on a page, all right? So that you catch the concept. So you don't have to go back and learn tonight on stats. It's done after the session. So the first thing we want to find is quartile 2. All right. Now quartile 2 is the halfway mark. So if we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, everyone going to find quartile 2, which is the median. In other words, find your median? Can someone give me the median?
8, so.
Right, it's in between these two numbers. Now, the good news is 8 plus 8 is 16 divided by 2. It will be 8. Now, what happens in a case where the numbers are even? It splits the data into two parts. So if we're looking at the data now, we have the bottom half and a top half. Now, to find quartile 1, Q1, it has to be the median of the bottom half. So quickly find quartile 1.
5 and 6, sir. Between 5 and 6.
Well done. 1, 2, 3, 4, 5, 6 numbers. And if we got 6 numbers, we can say that quartile 1 is between 5 plus 6 is 11. 11 divided by 2 is 5.5. And then we come to quartile 3. We're going to do the same thing for quartile 3. And it's between 9 plus 9 is 18 divided by 2 is 9. So there we have it. We call quartile 1 the lower quartile. Quartile 2 is called the median, and quartile 3 is called your upper quartile. Now, what happens here is each one represents 25% because it divides the data into 4 parts. One, if you're looking at this, just to show you what is happening here. So we have, that's your first set, 2, 3, 4. So if we have 4 parts, it's dividing each part. So that's 25% of the data. That's another 25% of the data. That's another 25% of the data. And there's your last 25% of the data, which means we can make a statement and say 25%. I don't know what this data means. So let's assume this data was heights of something. So we can say 25% are taller than 9. Or we could say 75% is below 9. So quartile 3, you can speak about it as being 25% over or 75% below. If you go to quartile 2, you're basically splitting 50%, 50%. Okay, now from here we get what we call an interquartile range. Now who can tell me what an interquartile range is? I'm waiting for you.
Highest quartile, upper quartile minus lower quartile.
Well done. Q3 minus Q1 is what we call an interquartile range. And we take 9. In other words, Q3 minus Q1 is 9 minus 5, 5.5, giving you 3.5. Now, another term that comes up is a semi. What is a semi-interquartile range? A semi means you must take your interquartile range, the word semi, like you get a semicircle, means half. So you take 3.5 and you will divide it by 2 to get a semi-interquartile range. Any questions? Okay. So now we go on to, from the data, okay, we're going to order. Now we know how to find the interquartile range. That's another example which I'm going to skip. I just want to get into, okay, so I want to get into now what we call a box and whisker diagram. So I just want to admit somebody else in. So let's look at a box and whisker diagram. Have you done a box and whisker diagram in class?
Yes, sir.
All right, very good. So a box and whisker diagram, basically we have a rectangle, as you can see. So in your rectangle, that represents Q1, Q2, the blue line is Q2 and Q3. And then your extreme ends will be your minimum and your maximum. So what we actually do is what we call a 5-point number summary, all right? So we call this a 5-point number summary. What is a 5-point number summary? The lowest value, which is your minimum, your Q1, lower quartile, your median, which is Q2, your upper quartile, which is Q3, and then your highest value, which is your maximum. So let's count 1, 2, 3, 4, 5. Those 5 values are what we call the 5-point number summary. And from the 5-point number summary, we get what we call a box and whisker diagram. So you can see you have a box, you got 2 whiskers, and the whiskers will run till the minimum and the maximum. So let's look at it in an example. So we want to draw a box plot for the data below. Now it's very important that you scale. If you don't scale, then you won't be able to see the skewness of the data. So if we work this out, sorry, a little too fast there. So there's our data. We're going to work out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we start with Q1, Q2, and Q3. So we know in between 8 and 8, we found Q2, which was 8. The lower quartile was 5.5, and the upper quartile is 9. We have our minimum, which is 4, and we have our maximum, which is 12. So we have our 5-point number summary. So I'm going to give you time, quickly draw your box and whisker diagram. When somebody's done, tell me done, then we can move on. I see we have 30 people joining us today. Some of you missed the hard sections and you came for the easy section.
Sorry, so I don't know if you said, but do you have to label anything for the box and whiskers diagram?
Okay, just draw it for now. We're going to look at it together. Let's see what you do. If you're not sure, then do more. All right, it's very important we have a scale. Your scale can run from, it doesn't have to run from 4. You can take it 1 below if you want. And we can use 1 centimeter intervals because the numbers are quite small. If we were dealing with big numbers, then I would suggest you count in tens. Every 1 centimeter could represent 10, or it could represent 50 or 100. So it depends on the data you have. So according to this, my box is at Q1, which is 5.5, in between 5 and 6. My Q3, so there's my rectangle going from 5.5 to 9. And then my median, according to the data here, will be sitting at, my median is sitting at 8. Okay, now I'm ready to draw my whiskers. So my first whisker is going out to 4, that's our minimum. And our second whisker is going out to 12. It's not necessary to label it, but if you want to, it's not a problem. Now you'll see that the left side of the box is bigger than the right side of the box. Okay, can I move on? Did everyone get this box and whisker diagram?
Yes, sir.
All right, so remember it comes from a 5-point number summary. Minimum, Q1, Q2, Q3, and your maximum. Let's take another example. We're going to draw a box plot for the data below. Give you some time, quickly sketch one. Let's see what it looks like.